Welcome. We want to solve for x in h raised to power x plus 2 raised to power x equals 30. Let's say solution. We have h raised to power x plus 2 raised to power x equals 130. So from here we can express this 8 as the power of 2 so that we have 2 raised to power 3, then it raised to power x plus 2 raised to power x equals 130. So from here, let's recall that if you have x raised to power p raised to power q, this will be equals x raised to power. When number which is raised to a certain power is again raised to another power, the powers are multiplied from the proper power law of indices. So, and this is still the same as x raised to power q raised to power p. So applying this to this, we will have 2 raised to power x raised to power 3 plus 2 raised to power x equals 130. So from here, we let our 2 raised to power x equals, let's use m. Let 2 raised to power x equals m. So here we'll have m raised to power 3 plus m equals 130. So from here, we can transfer this 130 to this side. So we'll have m raised to power 3 plus m minus 130 equals 0. So now we can express 130 as the product of 26 and 5. So, and if you have this m also will be expressed as 26m minus 25m. So this implies that we will have m raised to power 3. Let's replace m with this. We have minus 25m plus 26m. Then we have minus 130 equals 0. So let's factorize the common factor here. We have m multiplied by m squared minus 25 plus, what's the common factor here? That is 26. What we left here, we have m minus 5 equals 0. Therefore, we will have m. We can still express this as power of 5 so that we have m squared minus 5 raised to power 2 will give us 25 plus 26. Then we have m minus 5 equals 0. So looking at this difference of 2 square, this implies that we will have m minus 5 multiplied by m plus 5. Then also plus 26 multiplied by m minus 5 equals 0. So looking at this, you will see that we have a common factor of m minus 5 in this side and also at this side. So let's factorize m minus 5 out. So what we left with this, we have m times m plus 5. M multiplied by m plus 5, then plus. The only thing left here is 26 equals 0. What this means is this equals 0 and this equals 0. So we have m minus 5 equals 0, or m multiplied by m plus 5 plus 26 is equal to 0. So we have our first solution here, which will give us m equals 5. So, and here you will observe that this, if you expand this, we have m times m, we have m squared plus 5m, right, plus 26 equals 0. You observe this is a quadratic equation, but let's test the solution. So we have our a equals 1, b equals 5, and c equals 26. So to check, so we have delta equals b squared minus 4ac. All right. So let's substitute this value into this. We will have 5 raised to the power 2 minus 4 times 1 times 26. So we have our delta to be equals 5 raised to the power 2 will give us 25 minus 4 times 1 times 26 will give us 104, which means that our delta equals minus 79. But if you look at this, we will see that this is less than 0. So this means that this solution didn't have, this equation didn't have a resolution for this question. So however, we have to move on with m equals 5. But we are not asked to find m, rather we are asked to find x. So let's recall that 2 raised to the power x equals m, which implies 2 raised to the power x equals 5. So from here, if we introduce log to both sides, we'll have log 2 raised to the power x equals log 5. So here, if we apply the law of logarithm, this x will come forward. We have x log 2 equals log 5. So the next is to divide both sides by log 2. This will cancel out this. So we'll have x equals log 5 divided by log 2. But you must recall that if you have log x in base A divided by log y in base A, this is equals log x in base y. So applying this to this, we will have our x to be equals log 5 in base 2. So this is our solution to the equation.